Okay, today we're going to talk about some interesting sound phenomenon, namely the echo, the Doppler effect, and the sonic boom. You may have some experience with each of these. You might not have known what they were or how to describe them using physics terms, but today we are going to talk about how these work and what they really mean in physics terms. Okay, let's start with the echo. So you may have some experience with this if you were talking or speaking loudly, maybe in front of a large cliff or a large wall, and usually it starts by you creating some kind of a sound. So you stand there and you say hello, and the sound travels out to a different object, to a distant object like a large wall or a cliff wall, and the sound is reflected back. Okay, so you stand there, you say hello, and then a second or two later you hear yourself saying hello back, and you might hear it a couple of times as the sound bounces back and forth, like if you're in some kind of a cavern or something. Okay, now if you know the speed of sound, and you can time how long it takes for the sound to get from you to the wall and back, right? If you time that sound and see how long it takes for you to hear the repeat sound, then you would be able to calculate the distance and how far away that wall or that cavern is from you. Now, we're not going to have time today to do that, but hopefully within the next week we can do some of those calculations. All right, the Doppler effect is something you probably hear all the time as you're driving down the road and you hear a police car go by or an ambulance go by. And the way this works is the Doppler effect accounts for the different apparent frequency, and that's a big deal, this word apparent right here, because the frequency actually doesn't change. So the police car or the ambulance doesn't emit a different sound when it's coming towards you versus when it's leaving. It's just an apparent change that your ear picks up on. And it's because the source of the sound is moving, or perhaps the listener is moving. So this picture right here kind of describes why this works. So in this picture on the left over here, we have the source at rest, and here's you right there, you're not moving. And the car isn't moving either, so I don't know why we have this V going to the left, because the car is not moving at all. And what happens is that the car emits a sound, and these circles here, so this black circle, the red one, the green one, and the blue one, those represent the crests of the sound wave. And I know that, and you know that sound really is a longitudinal wave, and it doesn't have crests, it has compressions and rarefactions, but it's much easier to visualize if we can visualize those crests. So the way this works is that the police car, in this case, lets out a sound wave, and the wave travels away from it, right? So this first it creates this blue crest, and then it creates this green one, and the red one, and the black one. And you can see here over on the right that they're all the same distance apart as they are over here on the left. They're all the same distance apart, those crests. So you hear that wave, and you hear a certain frequency based on how far apart those crests are. So the farther apart the crests are, right, the longer the wavelength and the lower the frequency. So the lower the tune, you hear a bass note, right? If the crests get closer together, that's a higher frequency, so you hear a higher pitched sound, okay? So now let's look and see what's going on over here. Now you're over here, you're still standing still, but the police car is moving towards you, okay? So the police car maybe started out over here, right? And it emitted this blue crest. And then it moved a little bit to the right, the police car did, and it emitted the green crest. Then it moved a little bit more to the right, and we see the red crest, and then finally a little bit more to the right, and we see this black crest. Well, look over here what that has the effect of. Basically, we have scrunched together or smooshed together all of those crests so that there is an apparently higher frequency, right? The wavelength is smaller, the frequency is higher, okay? So what we hear is a higher pitch, okay? That's when we're standing and the car is coming towards us. If instead we were standing over here and the car was going away from us, we would see these sound waves with a much longer wavelength, and we would hear that deeper sound. So we can use that information then to determine if the car is coming towards us and when it passes us and starts to go away from us, because we'll hear that sound. So the next time you're on the road and you're listening to a police car or an ambulance going by you, notice how that sound changes after the car goes by you. Okay, so this is kind of just another example of what we would hear. So we got this guy over here in the blue shirt, and he looks like he's going to be hit by the police car. Hopefully he's not hit, right? But he's going to hear a higher pitch sound than the girl that's standing over here on the left, because she's going to hear a lower pitch sound, right? Because pitch just has to do with the frequency. So the lower the frequency, the lower the pitch, and the longer the wavelength, okay? So you can think of this as the car is moving towards you. The wavelength is getting much shorter because the waves are getting bunched together and we're getting that higher frequency. And in a little bit you guys are going to watch a video and you're going to be able to hear how that works in action. Okay, so that's the Doppler effect and how that works. Alright, the last thing we're going to talk about is the sonic boom. And the sonic boom is related to the Doppler effect, which is why I wanted to talk about that first. But if you've ever heard a sonic boom, it's probably when you were watching an airplane go by. Maybe you're at the Chicago Air and Water Show, and the airplane goes by, and you hear this huge boom sound. Okay, this graphic right here hopefully will explain why. Okay, so if we look here, as the aircraft travels, it compresses the air ahead of it. Okay, so if it's going very slowly, right, we won't get a lot of compression. But as the aircraft approaches the speed of sound, what happens is that all these compressions bunch up in one location. Okay, so you're kind of having all this sound created right here, and all that sound is bunching up right there. Well, then when this wave finally gets to the listener, perhaps that's you on the ground here in the downtown Chicago, you hear a big boom because you're getting all that sound. It's building up all at once. Then, if the aircraft continues to go even faster than the speed of sound, you get a cone of large sound that kind of trails behind the airplane. Okay, so you'll hear that loud sound for a little bit until finally the plane has gone far enough away that you're not going to get that large compression anymore. Okay, but what's happening is, and the biggest misconception with sonic booms is that you only hear it right when the airplane has kind of broken the sound barrier. Okay, the sound barrier is just it's kind of an old, I don't want to say it's a myth, but it was a misconception because people thought that going past the speed of sound might be impossible. In fact, it's very possible. Airplanes do it all the time. Okay, so breaking the speed of sound is not necessarily when you will hear the sonic boom. It's true, the airplane has to go faster than the speed of sound, but you'll hear it when the aircraft gets past you, just past you, because you'll hear all that bunching up of the sound. Okay, the aircraft has been traveling past the speed of sound for quite some time. It doesn't matter that it just broke the sonic sound barrier. Okay, all right, one more little slide here. One more little slide. So this just shows another airplane, and this airplane is going faster than the speed of sound, and we see right here this blue line is kind of the bunching up of all of the sound waves. And here's you down here, and you're listening. And when the plane was somewhere over here, right, it's going past you, and right about here we finally get to the point where we can hear that sound. So we hear all that sound that right kind of at the same instant, and we get that big sonic boom. Okay, so that is kind of some interesting phenomenon. Kind of in a quick nutshell, you're going to watch some videos right now, and then hopefully you will understand those ideas a little bit better. All right, enjoy the rest of your class.